Design of beam. Design a beam of span 5.71 meter where breadth is taken as 0.3 meter. FCK is equal to 25 Newton per mm square. Fy is equal to 500 Newton per mm square. Mu, that is moment, is equal to 14.718 kilonewton meter. Vu, that is shear force, which is equal to 128.22 kilonewton. Effective depth and span calculation. Effective depth is equal to span divided by 20. So span is equal to 5710 divided by 20, which is equal to 285.5 mm, which is taken as 300 mm. Assume cover is equal to 50 mm, that is d dash is equal to 50 mm. Therefore, overall depth is equal to effective depth plus cover. Therefore, it is 300 mm plus 50 mm, which is equal to 350 mm. Next is main reinforcement calculation. From IS 456-2000, page number 96, we have the formula mu limit is equal to 0.36 into xu max divided by d into 1 minus 0.42 xu max divided by d into FCK PD square. Therefore, it is 0.36 into xu max divided by d value is 0.48. So, it is substituted here into 1 minus 0.42 into 0.48 into FCK value is 25, B is 300, D is 300. So, it is substituted. Value of mu limit is equal to 93.12 kilonewton meter. So, we know the value of mu, that is 14.7 kilonewton meter. Therefore, the condition is mu is less than mu limit. Hence, provide doubly reinforced beam. Compression reinforcement. FSC is equal to 0.0035 into xu max minus d dash divided by xu max into ES, where xu max is equal to 0.48 into d. 0.48 into d is the effective depth of the beam, which is equal to 144 mm. Therefore, FSC is equal to 0.0035 into 144 mm minus 50, that is cover of the beam, divided by 144 into 2 into 10 power 5, that is the Young's modulus of the steel, that is ES value is equal to 2 into 10 power 5, which is equal to 478.8 Newton per mm square. So, we are going to check with this condition. FSC should be less than 0.87 of Fy. So, we are going to calculate the value of 0.87 Fy, which is equal to 0.87 into 500, that is 435 Newton per mm square, which is less than the value of FSC. So, we are taking the value of FSC as 435 Newton per mm square. Now, ASC, that is compression reinforcement, is equal to mu minus mu limit divided by FSC into d minus d dash. So, mu minus mu limit value is 78.4 into 10 power 6 divided by FSC value is 435 into d value is 300, d dash value is 50. So, ASC is equal to 720.91 mm square. Assume 16 mm dia is used. Therefore, number of bars is equal to AC divided by AC. AC is the calculated compression reinforcement divided by pi by 4 into diameter of the rod we are using. So, it is pi by 4 into 16 square. Therefore, provide 4 bars of 20 mm dia bars of Fe 500 grade of steel as the compression reinforcement in the beam. Next is tensile reinforcement. So, for tensile reinforcement, we will be calculating as 2 parts, that is AST is equal to AST1 plus AST2. So, first initially we are going to calculate AST2. So, AST2 is equal to ASC into FSC divided by 0.87 Fy. So, we know the value of ASC as 720.91 into FSC value is 435. We have taken it from 0.87 of Fy. Then divided by 0.87 into 500, which is equal to 720.91 mm square. Now we are going to calculate AST1. AST1 is equal to XU max divided by D into 0.36 into FCKBD divided by 0.87 FY. So we know the value of XU max divided by D as 0.48 into 0.36 into FCK is equal to 25, B is equal to 300, D is equal to 300 divided by 0.87 into Fy is equal to 500. So while substituting all these values, we are getting AST1 as 895.13 mm square. Therefore, area of tension reinforcement is equal to AST1 plus AST2, that is 720.91 plus 895.13, which is equal to 1614.64 mm square. So we are using 25 mm dia bars. Therefore, number of bars is equal to AST divided by AST, that is total tension reinforcement divided by area of a single reinforcing bar, that is 1614.64 divided by pi by 4 into 25 square. Therefore, number of bars is equal to 5. So, provide 5 numbers of 25 mm dia bars of Fe 500 grade of steel as the main tensile reinforcement in the beam. Check for shear force. First we are going to calculate nominal shear stress value and permissible shear stress value, and we are going to compare them. So nominal shear stress is equal to Vu divided by B into D. Vu value we already know, it is 128.221 into 10 power 3, which is substituted for converting from kilonewton to newton, divided by B is equal to 300 and D is equal to 300. Therefore, the value of nominal shear stress, that is tau V, is equal to 1.22 Newton per mm square. Next is permissible shear stress, that is percentage AST, which is equal to 100 AST divided by B into D. So we know all the values, we are substituting it, we will getting the answer as 1.40%. Therefore, tau C is equal to 0.73. So we are comparing the values of tau V and tau C. Tau V is greater than tau C, hence shear reinforcement is required to be designed for the safe shear distribution. So now we are designing shear reinforcement. Adopt 2-legged stirrups of 8 mm dia. ASV is equal to 100.53 mm square. VUS is equal to, we have the formula VU minus tau C into B into D. Vu value is 128.22 into 10 to the power 3 minus tau C value is 0.73, B is equal to 300, D is equal to 300. Therefore, VUS value is equal to 93.4 kilonewton. Next is spacing. SV is equal to 0.87 into F by ASV into D divided by VUS. So 0.87 into Fy value is 500, ASV value is 100.53 mm square, D is equal to 300 divided by VUS value is 93.4 into 10 power 3. Therefore, we will get the spacing as 100 mm. So provide 2-legged vertical stirrups of 8 mm dia of Fe 500 grade of steel at 100 mm center to center spacing. So this is the reinforcement detailing of the beam which we have designed now. So this is compression reinforcement and this is tensile reinforcement. So compression reinforcement is 4 numbers of 20 mm dia bars, and this is the tensile reinforcement, that is 5 numbers of 25 mm dia bars is given. So in this image of reinforcement detailing, we can clearly see the stirrups, that is shear reinforcement, which we have provided as 8 mm dia bars at 100 mm center to center spacing. This is the tension reinforcement, 5 numbers of 25 mm dia bars, and this is the compression reinforcement, 4 numbers of 20 mm dia bars. Thank you for watching our video. For more videos, subscribe to our channel.